As you know, these processes underlie the kidney's integral role in determining the composition and characteristics of circulating blood, including pH, electrolyte concentration, water content, and, central to our discussion today, glucose levels. Renal filtration and reabsorption are carried out in the nephron, the structural and functional unit of the kidney. The nephron consists of a capillary network called the glomerulus and a tubular system in which substances either are reabsorbed from the glomerular filtrate or remain in the tubules, where they are collected as waste products to be eliminated in the urine. Blood that enters the glomerulus is under relatively high pressure, which forces water, salts, glucose, and other small metabolites out of the capillaries and into the surrounding Bowman's capsule of the tubular component. The filtrate then passes through what are called the S1, S2, and S3 segments of the proximal tubule, the loop of Henle, and the distal tubule, before leaving the nephron and entering the collecting duct system. In healthy individuals, the total GFR, glomerular filtration rate, is around 180 liters of plasma per day, which, based on an average plasma glucose of 90 milligrams per deciliter, corresponds to approximately 160 grams of glucose filtered out of the plasma every 24 hours. Normally, virtually all of that glucose is reabsorbed in the proximal tubule of the nephron. This glucose reabsorption process is mediated by the sodium glucose cotransporters, or SGLTs, which move glucose from the tubular lumen into the epithelial cells lining the tubule. Approximately 90% of the glucose is reabsorbed by high-capacity, low-affinity SGLT2, which is specifically expressed in the S1 and S2 segments of the proximal tubule. The remaining 10% of the filtered glucose is reabsorbed by low-capacity, high-affinity SGLT1, which is expressed in the S3 segment. SGLT1 is also expressed in the brush border or the small intestine, where it functions to absorb dietary glucose and galactose. Transporting glucose out of the tubule lumen is an active process that works against a glucose concentration gradient. To accomplish this, SGLTs rely on energy stored in an electrochemical sodium gradient, coupling glucose transport through movement of sodium ions into the epithelial cell. Once inside the cells, glucose diffuses to the basolateral membrane and passively moves into the bloodstream via facilitative glucose transporters.